Section 6.1, simplifying a rational function. In this problem, they're asking us to simplify and list all restrictions on the domain. A number is not in the domain of a rational function if it makes a divisor 0. There are 4 divisors in this rational function. We have the obvious first one, t minus 2. We have this, which looks like the divisor right now because of it being in the denominator. But when we invert it, this numerator also will be a divisor that we'll have to watch for a restriction. And then this denominator will be part of our restriction as well. So we will want to avoid when t minus 2 equals 0, which is when t is equal to 2, when you add 2 to both sides. We will want to avoid t squared plus 4t plus 3 equaling 0 for restriction. Factoring this, we end up with a t plus 3 times a t plus 1 is equal to 0, which, setting each of these factors equal to 0, t plus 3 equals 0 or t plus 1 equals 0 from our zero product property, gives us a t is equal to negative 3, or subtracting a 1 from each side, t is equal to a negative 1. So we have so far a t equals 2, a t equals negative 3, a t equals negative 1. Those will cause zeros in the denominator that we will restrict our domain from those values. Also, currently as it stands, we've taken care of the denominator, but because it's a division by this rational expression, we also will end up having this numerator come to the denominator as a divisor. So we will not want t squared minus 9 to equal 0. Factoring, this is a difference of squares. We get a t minus 3 and a t plus 3 equals 0. The product of two things equals 0 means t minus 3 equals 0 or t plus 3 equals 0. Adding a 3 to both sides, we have a restriction of t equals 3. And subtracting a 3 from each side, we get a negative 3. Well, we already had our negative 3, but we now add a t equal 3 for our restriction. And our last one is our denominator here. When will it equal 0? Something we want to avoid. When we subtract a 1, we end up with t is equal to a negative 1, which was also part of our list. So our domain will be x such that x is an element of all real numbers except x cannot be a positive and negative 3, it cannot be a 1, negative 1, and it also cannot be a 2. Those are the values that are part of our restriction so that we don't run into a division by 0 error. Then what we're going to do is we're going to look at our function and simplify it. So nothing as far as factoring our first rational expression. Division means we invert and multiply, so this fraction will switch places. The t squared plus 4t plus 3 will go to the numerator, which factors into a t plus 3 and a t plus 1. The denominator is a difference of squares. We factored that a minute ago, t minus 3 and t plus 3. And in the numerator of our last rational, we're multiplying. Let's factor that. We have a 4 times t minus 2 when we factor out a greatest common factor of 4, and we have a t plus 1. Now we have the fun of canceling out, if possible, any common factors. We have a t plus 3 common. which is equivalent to 1. We have a t plus 1, which is common to the numerator and denominator, which is equal to 1. We also have a t minus 2 factor in the numerator and denominator. Anytime you have the same thing over the same thing, it equals to 1. What is left? We have our integer of 4 times the binomial t plus 3 over the common denominator of t minus 3. This factor is not the same as the factor in the numerator. Furthermore, it's probably a good idea to leave it out in factored form rather than distributive so that we can see that it is in its reduced form. So the simplification of f of t is the following with the restriction on our domain.